Have you ever wondered how we can be so sure that the Earth is spinning on its axis? We don't feel it moving, right? Well, back in 1851, a French physicist named Jean-Bernard Léon Foucault came up with a brilliantly simple experiment to prove it once and for all. He unveiled it at the Grand Pantheon in Paris, and it's now famously known as the Foucault pendulum. So what is it? Imagine a very long, heavy pendulum suspended from a high ceiling, free to swing back and forth. The magic behind it is based on a fundamental principle of physics. Once you set it swinging, its plane of oscillation, that's the back and forth path it takes, stays fixed in space. Think of it like it's pointing towards a distant star, and it doesn't want to change its direction. Now here's where it gets mind-bending. If you were to watch this pendulum for a whole day, you would swear that its swing is slowly rotating. You'd see the path it traces on the floor shifting bit by bit. But here's the secret. The pendulum isn't the one turning. We are. The Earth, along with the building and everyone in it, is rotating right underneath the swinging pendulum. This creates the illusion that the pendulum's swing is changing direction. It's a direct visual proof that our planet is in constant motion. What's even more fascinating is that how fast this apparent rotation happens depends entirely on where you are on Earth. If you set up a Foucault pendulum at the North or South Pole, its swing would appear to complete a full 360-degree circle in about 24 hours, perfectly matching the Earth's rotation. But what if you were at the equator? There, the pendulum's swing wouldn't appear to rotate at all. It would just keep swinging back and forth along the same line relative to the ground. For any location in between, like where most of us live, the rotation happens, but it takes longer than 24 hours to complete a full circle. The direction of the rotation also tells you something cool. In the northern hemisphere, it appears to turn clockwise, and in the southern hemisphere, it's counterclockwise. This whole effect is caused by what scientists call the Coriolis force, which is an effect that appears in rotating systems like our planet. So, the Foucault pendulum isn't just a heavy ball on a string. It's an elegant, powerful demonstration that turns a scientific concept into something we can see with our own eyes. It's a silent, constant dance between physics and our rotating world. Thanks for watching.